Hi, I'm Sam Patterson, and welcome to Beyond the Hour of Code, the podcast where I talk about the things we do to keep up with what we have to know in order to teach. I am a Makerspace STEAM coordinator at Echo Horizon School in LA, and I work with pre-kindergarten through 6th grade students. Every day we're doing making, we're doing building, we're coding, and I'm always trying to make sure that these activities are as authentic as possible, that we're doing things for a reason that's important to my students. And I know that a big part of keeping everything authentic is finding authentic reasons to use tech in my own life. And that's what today's episode is about. I'm going to talk about a couple of the projects that I've kind of drummed up here myself in order to get myself to learn how to do things that my kids need to know how to do. When I inherited my makerspace from the previous instructor, there was tech there that I didn't know, and some of it I still don't know. The first two projects I'm going to talk about today are based on the LilyPad Arduino, and there were several of these in my makerspace when I started. The LilyPad Arduino, if you aren't familiar with it, is an Arduino board that's often used in wearable technology. So if you're going to sew lights into something or make an interactive garment, you might end up using the LilyPad platform at the base of that because it's designed with circuit sewing in mind. I've got this project, which is actually a big red puppet. His name is Notorious LED, and he loves to read. He's a regular on my YouTube channel. Whoa! Thank you, LED. And, yeah, I love to read. Yes, they know. And he's called Notorious LED because he has LEDs in his chest. I was at a workshop with Sylvia Martinez and Gary Steger several years ago, and I put 3 LEDs in his chest. That was 1.0. This NeoPixel ring is much fancier than that and was a serious upgrade. Notorious LED has been under development for almost 2 years now. I'm never done! And that's the kind of thing about some of these projects. They are never done. So I did some work on him. I sent him to a friend of mine, Jeff Branson, who installed the LilyPad and the NeoPixel ring. I've been working again on his code, trying to get the lights to be a little lower, because when I put him on camera with the lights, it blows out the white level. You know, it's all of these great details. Right now, what I'm trying to do is I'm trying to figure out if I can upgrade the code and add this little sound detecting device to make the lights he has pulse when he talks. Along with my voice? Yes, along with your voice. That sounds amazing! And it will be amazing if I can ever figure out how to do it. But that's a project that I've just, added a little bit of hardware to, and now I'm working with the code back and forth. And I'm not, super confident with code. I have to try things out, and if it doesn't work, I end up emailing a bunch of people saying, why isn't this working? Here's what I'm doing. And when I'm really lucky, they get back to me and share where I've made my mistakes. The other project that I'm working on with the LilyPad is a blinking backpack. So I have this backpack that is a galaxy design, and I want to put little sparkling lights in it. And I want it to be kind of complex and interactive. I'm not sure how many different inputs I want it to respond to, but I had thought about doing this just with the small LilyPad Twinkle, which is just a simple kind of controller that already has a pre-built twinkle sequence in it, but I wanted it to be able to do more than that. I don't know how much more, but I really want the backpack to be kind of a platform that the kids might even be able to try out some programming on before they build their own wearables. So I'm looking to build kind of this example wearable. And I've been using a slightly different LilyPad board on that, and it's got some significant troubleshooting issues that I've run into. And now I've switched back to the first LilyPad board. And a lot of this ends up being, do you know how to figure things out and solve problems? If not, how do you figure out how to figure things out and solve problems? And then trying to unpack that experience so I could bring it to my students. the thing with these projects is I'm not getting them done in 90-minute sessions. I'm not doing it in like a month worth of classwork. I'm doing it in a year's worth of spare moments. And even then, they're not totally successful, right? So this whole process-based thing really makes a lot more sense once you've spent a couple years trying to get one puppet to work right, and you have all of these other things going on at the same time. So that's, a lesson that I think it's important for us as teachers to constantly bring our head back into, that, this stuff doesn't work quickly and doesn't, there's always unanticipated problems, and it's really how you document, move forward, reflect, etc. through that. So those two projects, the puppet and the backpack, are kind of my lily pad Arduino based projects. And then I'm doing two other things. One is a project that I'm working on with 3rd through 5th grade, basically, right now, where all of the grades are building these little cardboard houses. They're designing them in Google Draw, and then we're cutting them out on the laser cutter. And 4th grade is wiring them for lights. And then they're going to wire a power grid or build a power grid circuit, basically, to power these lights. And we are going to work up from batteries to microbit controlled programming to deliver the power. So this is kind of taking your future city design project mode of learning, as well as which I can incorporate some design thinking into, because we can interview actual people, and adding, series and parallel circuit construction to it. So my hope is that as they try to do more and more complex arrangements of these lights and circuits, they're required to construct more and more sophisticated circuits and power systems to deliver the effect they want. So far, so good. It's really neat. I've been playing around with the microbit and the Make Code website. If you haven't had a chance to get your hands on a microbit, I think they're $15, $20, something like that. Really a great kind of board for doing a lot of different things. And you can control LEDs as well as NeoPixel strings with them. So a couple weeks ago, I finally figured out how to fire up the 156 LED strand that had been sitting in my closet, and it will now dance in rainbow lights, which makes me very excited, because that required not only using the microbit and a breakout board to connect it to a breadboard, I also needed to create my own power source for that, so I dissected a USB cable and turned that into a positive and negative lead, which wasn't something I'd done before, and I only melted the breadboard a little bit the first time I hooked it up wrong. So, there's all of that there. And there's other projects on the horizon. Next time when we talk, I'm going to be sharing a little bit about an onboard diagnostics device that I'm going to be making for my car, and I'll give you an update on the LED building project, and we may have some Sam's Labs equipment to look at. So I hope this has got you thinking a little bit about how you might make coding relevant and hardware programming relevant in your own life, so you can bring that relevance to your students and say, see, I found this legitimate reason. Let's help you find your legitimate reason. And drop me a line at SAMPATUE on Twitter. You can find me at mypaperlessclassroom.com and beyondthehourofcode.com.